This is 5.7. We're going to play with functions, because why not? All right, so we're using these functions, and as a quick review, so if you have f of x equals this thing, and then g of x equals this thing, so if we were going to find something like f of x plus g of x, this is a problem that we've done before. You just take this thing, plug it in right there, this thing, plug it in right there, and then you just solve from there. So here's my f of x, here's my g of x, we combine them, here's our answer. So that's kind of a thing that we've done before, and we can call this new function f plus g of x. So that would look something like f plus g of x. So that's what it would look like. So there's a bunch of properties that makes all of this, kind of easier. And I feel like they're kind of intuitive. It's going to be kind of up to you, but here it is. So when we're doing sums, so we're adding things together, that is the same as you can separate your two functions out. So if you have your f and you have your g, you can solve it by separating those two out and then just adding them together. Same thing is true with subtract, but make sure that this negative sign gets distributed all into the g of x, or whichever function goes next. So same is true with multiplication. You can separate those out, and then same is true with quotients or division. You can separate this out. This has a little asterisk by it because that just means that g of x is not allowed to equal 0. If g of x equals 0, then you're going to get either infinity. Well, you can't divide by 0. So that's the only caveat with there. So g of x cannot equal 0. So other than that, you're just essentially plugging stuff in and using whichever form is easier. It's generally going to be this form over here where you're just going to have an entire function. This is that time where you kind of got to focus in, and when you plug in each individual chunk, it becomes less crazy. So let's try some examples. Okay, so number one, it gives us some functions up here, and then we're supposed to add them together. So let's go for it. So this one, based on our property, this is not something that you have to write down, but we can divide this up into f of x plus g of x, and that is something that we can find up here. So now we're just going to plug those two things in and then add them. So my f of x is x squared minus 8x plus 4, and then we're going to add that to my g of x, which is 4x minus 3. Okay, so there is no distribution that needs to happen, so I can just combine like terms. I only see one x squared. I see two x's that need to be combined. So negative 8 plus 4 is going to be negative 4x. I see two regular numbers, quote unquote. So positive 4 minus 3 is going to be plus 1. And that's it. So we're going to do the same thing with number 2. We're just using a minus sign. Just be careful to make sure that you distribute your negative sign if you're subtracting. So we've got f minus h. So we could rewrite that as f of x minus h of x. I forgot what those were, so we're going to have to look at that. So our f of x is going to be x squared minus 8x plus 4. And especially when you're subtracting, it's really important to use your parentheses. They're going to make sure that you correctly distribute that negative sign. Okay, so I just plugged in my two functions. So now I'm going to distribute my negative sign, make sure that it hits both of my numbers. So I could rewrite the whole thing. I'm going to do that here. You don't necessarily have to rewrite everything every single time, but if it helps you understand, then it helps you understand. So this negative sign is going to hit that x, then that negative sign is going to hit that 2. So then from there, combine like terms. I only see one x squared. I see a negative 8x and a negative x, so that's going to be minus 9x. I see a 4 and then a negative 2, which is going to be plus 2. And there's our answer. So for number 3, we are multiplying them together. So you could rewrite it as h of x times g of x. I took the liberty of rewriting it here because I can't remember what the functions were, so I had to look at it. And from there, you're just going to have to FOIL it out. So it's a really good practice to write this stuff out just so that you don't forget to do something correctly. So when I see that, I know that I'm foiling it. So that's going to be x going to those two guys. So I got 4x squared minus 3x. Then my 2 is going to be a plus 8x. And then that's going to be a minus 6. We're going to combine like terms. 4x squared. 8 minus 3 is 5x. And then negative 6 is by itself. So here we go. So number 4, I kind of accidentally did for you, but I'm sure that's okay. So f is on the top, h is on the bottom. So I just plugged in f for the top, and I plugged in h for the bottom. And then I was looking at, so I would immediately look at this and be like, oh my gosh, I really hope it's factorable. This is not factorable that I can figure out. And so this is our answer. But the catch is that anytime you have a fraction, that denominator cannot equal 0. So it's important, your domain and all the previous ones is all real numbers, but here we need to outline that our domain is x does not equal negative 2. Because remember, if anything, or 0 cannot go on the bottom of a fraction. So I skipped down to number 7. You will notice that these have a number. So instead of finding the function of x, we are finding f plus g of negative 2. That means we're plugging in negative 2. Now the fun part about this is that you can plug that negative 2 in anytime you want. You can either do what we were doing above and list everything out, combine like terms, and then plug in the number, or you can plug in the number at first and then add the 2. So remember, we've got f plus g, so that's kind of like f of x plus g of x. So we can find f of x, and then we can find g of x, and then we can add them together. So that's what I'm going to do this time. So our f of x is equal, actually I should say our f of negative 2 is equal to what? Okay, so 2 negative 2 squared minus a negative 2 minus 12. So I got that from up here, and then I plugged in negative 2 everywhere where I found an x. So let's see here, we got, that's going to be a 4, 8. So we're going to have 8 minus plus 2 minus 12, positive 2 and negative 12. We're going to have negative 10. And 8 minus 10 is negative 2. So f of negative 2 equals negative 2. So now we're going to do our g of x, or our g of negative 2, and that's going to equal negative 2 plus 7. Oh, much easier. 10, 9, 8, 7, 6, 5. So that's going to equal 5. So g of negative 2 equals 5. So now we're looking at this right here. We're just going to plug in those two values, and we're going to add them together. So we've got negative 2. Here, I'll keep my colors consistent. Negative 2 plus 5 equals 3. Done. So the rest of these are going to be done the same way. You can just split them up, evaluate each function, and then do the operation. So these are going to multiply together, divide, and then subtract. Just make sure that the divide and by, if you get something crazy like a 0 on the bottom, then you are going to call that undefined. I can tell you right now This one is not going to be undefined. But I want to skip ahead to compositions. So compositions of functions is basically having a function within a function within a function, or however many times you go out. So a new symbol that we have not seen yet. So this is a new symbol. So this reads f of g of x. Okay, so that means that you're combining f of x and g of x. And what that means is you're taking the function of x. So it gets a little confusing, but chunk it out. So like to solve these problems, you can rewrite it like that if you want, but ultimately you're gonna solve this one inside of here. You're gonna take that answer and then you're gonna plug it into the f function, whatever that one is. So it's a new thing, it's a new symbol. So this just is like an open circle. You'll see them a little bit more later on. And it just is f of g of x. So we're taking a function of x. So I'm looking at number 11. That is f of g of x. So that's the same as saying f of g of x. So I'm going to first just solve for g of x. So my g of x is equal to x minus 1. So now I'm going to take that g of x and plug it into my f of x. So here's my f of x up here. So now everywhere I see an x in my f function, we're going to plug in this entire thing. Okay? Everywhere where we see an x, we're going to plug in that entire thing. So when I'm writing out my function, I start off with an x cubed. So we're going to have x minus 1 cubed, and then that's it, plus 8. Okay. So then from there, we are just going to solve. So unless you remember the pattern, there is a specific pattern that goes along with that. I would just write it out. That's my kind of go-to, and that's what I do anytime I don't remember patterns, because I don't remember patterns very much. So I'll switch colors so it's easier to see. So I'm going to write out x minus 1, x minus 1, x minus 1, plus 8. I'm going to do the first two, only the first two. So we're going to take x times x, x squared, x times negative 1, negative 1x, negative 1 times x, negative 1x, negative 1 times 1, plus 1. And I'm just going to put parentheses around that, and everything else is just going to come down. Make sure you don't lose things. A lot of times people will get so focused on one part, they'll just drop the other part of the equation. Make sure that you keep those pieces of the equation intact. So here we can combine like terms. So now we've got x squared minus 2x plus 1, x minus 1 plus 8. Okay, so now we're going to multiply all those together. So x squared times x is going to be x cubed. X squared times negative 1 is going to be negative x squared. Negative 2 times x is negative 2x squared. Negative 2x times negative 1 is negative positive 2x. And then 1 times x is x. 1 times negative 1 is negative 1. Then don't forget to bring your plus 8 down here. So this is where different colors kind of helps out a whole bunch. So if I'm looking at, I need to combine like terms, right? So I've got an x squared here and an x squared here. I've got an x and an x. Oh, they all conveniently lined up right next to each other. That's not always the case, but whatever. So now you're going to combine like terms, and then we'll be done with this problem. So we'll do the final answer in red. We have x cubed. There's no other x cubes I need to combine with. We have a negative x squared and a negative 2x squared minus 3x squared. 2x plus x plus 3x. -1 plus 8 plus 7. And that is our answer. So conceptually, not terrible if you chunk it out and find one piece, plug that piece into the next piece, plug that piece into the next piece, and make sure that we do good algebra and good bookkeeping to ensure that we don't drop anything out. So I'm looking at number 12 here, and again, this is h of g of x. So we're going to start from our inside and work our way out. So g of x is just x minus 1. So now we're going to look at h of x, and anywhere where we see an x in the h of x, we're going to plug in x minus 1. So now we have h of g of x is going to equal, let's see here. Here is my f, or my h of x. So we're going to have 5x, and in that case, we're going to plug in our g of x, so that's x minus 1, and then minus 3. And then from there, we're just going to solve, or simplify, I should say. So we're going to distribute the 5 in, so now we've got 5x minus 5 minus 3. We'll combine like terms. We have 5x minus 5, 6, 7, 8. And that's going to be our answer that time. So that's what we're going to do with all these problems. The only change is that down here, and we'll see this in our practice problems, here we've got a number that we can plug in. And again, that makes it even easier. So whichever one is on the inside, you will plug that number into that function, get a number, take that number, and then plug it into the outside function.